So we know that these air quality standards apply to outdoor or ambient air. So these are monitored by the EPA, and we have, as a result, cleaner air since 1970, except for some days where there's some anomalies. But what about indoor air? So indoor air is not regulated, not by any government organization, not by anyone. That's because there are too many indoor air spaces that are different. So individual homes, individual offices, individual restaurants can't be regulated. So what indoor pollutants are there in indoors spaces? We have all of the outdoor air pollutants. So we have carbon monoxide, we have nitrogen dioxide, ozone, particulate matter, and sulfur dioxide. We have all of those outdoor air pollutants that are also inside. So all of the above are also indoor air pollutants, plus a few more. So let's get into what those are. For indoor air pollutants, do you even think about them? You think about where outdoor air pollutants are created from coal-fired power plants or from gasoline combustion engine exhaust, but indoor air pollutants come from things that we do inside, like lighting a candle or incense or paint. Use paint to paint the walls, or even just use paint in an art project. So the additional indoor air pollutants are from combustion reactions. We have carbon monoxide and soot. And carbon monoxide as an indoor air pollutant, many of you guys have already noted, is fairly dangerous. And that's when you do not vent carbon monoxide, it can be lethal. This is an example of what are called volatile organic compounds coming from paints. So this is painting a wall or even small amount of paint in an art project. These are volatile organic compounds. Volatile means they're easily turned into gases. So this paint is a liquid in here. But these are gases that easily diffuse and move into the air in an indoor space. And the reason why they're volatile, that this paint easily releases gases, is because they're organic compounds. We'll get into organic compounds much later into chapter 12, but organic compounds are carbon-containing compounds. So some volatile organic compounds are naturally occurring, like the smell of a strawberry, or from a flower, the scent of a rose. Those are volatile organic compounds as well. If you can smell something, it's a gas and it's coming to you from the source, which was the natural product. But other volatile organic compounds, so paints are an example of a non-natural, or cigarette smoke, anything with an odor that's a gas. These are all gases that have odors, smells. They can be good, like this diffuser, but anything that is a gas that could be an indoor air pollutant, you might want to think about where it's coming from. So you'd have this trail of black soot coming from a candle or a fire if you lit a fire indoors. And this is equivalent to having this from car exhaust. So it's from a combustion reaction. Okay, and so combustion is when you are burning a hydrocarbon in the presence of oxygen. So in oxygen gas or O2. So indoor air pollutants, what we have, stale air, vapors, cigarette smoke, bacteria, germs. We'll get into this on this checklist, radon. Okay, radon is a special case of an indoor air pollutant. So radon is a naturally present. Nobody put it there. It is not from any reaction in your house, but it depends on your location. So radon is naturally emitted from the ground, from rocks and from dirt, from basically the earth underneath you. And radon is the element symbol Rn. It is a noble gas in family 8A. So it's not reactive. It doesn't cause chemical reactions, but it is just present in different amounts all over the planet and all throughout the universe. And so how much radon is underneath your house in the dirt and rocks is dependent on where your house is. So What radon does do over long periods of time and long periods of exposure is radon causes lung cancer. So it is monitored. And so basically one thing you can do if you are concerned, do I have radon in my house, is you can buy a radon test kit. So this is a home radon test kit to test for radon gas in your home. And this is linked to how much radon is coming up from underground, which you can't know. But what happens in homes is it accumulates in the home, and it will accumulate in the house, and then you'll have this polluted indoor air. So if you find that you have radon in your home, you can do a lot of things about it. You can make sure your home is properly ventilated, just like ventilating for carbon monoxide. You can also make sure that you don't buy a home with radon in the first place. And that's one thing we're fortunate on the west coast of the United States, that our underground, our earth and rocks generally don't have much radon present. So it becomes a problem for homes which are, say, in colder climates where you never open the windows or doors, and the radon will accumulate. But so even if you had a home here and you had a lot of radon produced from underground, because we're constantly opening windows and doors and ventilating, you generally are removing the radon from your home. So combustion reactions that produce carbon monoxide are a problem when there's not proper ventilation. So that's carbon monoxide. That's the chemical name for this covalent compound. And so this is a problem not so much in the developed world, but it is in developing countries where they have indoor cooking. So if you're cooking, let's say outdoors using methane gas. So this is CH4 methane gas. This is wood. These are both combustion reactions. And this is a problem if you have an outdoor fire and you move it indoors. What you're doing is you are collecting all of that carbon dioxide that's produced, carbon monoxide, and soot. And so this is the case for 3 billion people living in undeveloped countries where cook stoves and fires are used indoors, not just for cooking, but for heating. Okay, so, and this is used outdoors, so that's fine, but for cooking and heating indoors, 3 billion people on the planet are being exposed to unnecessary amounts of indoor carbon monoxide. Just as a reminder that we talk about green chemistry in Chem 9, and in green chemistry we talk about green processes, using less energy, creating less waste, using fewer resources, or using renewable resources. And so this is one thing about VOCs, is using paints to paint the walls in your home that have less or no VOCs. You'll see that on paint labels. A no VOC paint is moving towards the direction of being green in your own home. So there are other examples you can see here, but getting rid of plastics, basically consumer products, controlling your organic solvents, removing arsenic from touch screens of that smartphone. All of these are moving towards green chemistry of our consumer products.